Hi my friends, today we continue with iLogic by presenting a continuation of the previous tutorial 149, but only if you tried to do what is told by me in that tutorial. Before I begin, I want to draw your attention to one important aspect. This is the previous tutorial. We select some parameters to be included in the form. Which are they? They are height. And if you go down, you see the description. This is the description. And the last paragraph, if you want to practice the topics in this series of tutorials, please download the synonymous zip files where appropriate from here. Appropriate is also the tutorial 149 because you can download from this site the this part from behind. What is now the continuation? As you can see, we'll try to add other entities beside the forms, namely rules. We can create rules and we can use them in forms. You have to be careful to my presentation and you'll find out a lot of new and interesting things with a simple presentation, not programming or other complicated things. I want you to like what I present here. Let's go to the problem. This is the part in the situation which was at the end of the previous tutorial. You find here the form. Yes. Click on the form and modify in 3 steps each of that features. You know this, yes? What is to make now? Now I want you to change the steps. This is a slider with 3 steps. Let's edit the form. It's very easy. Select the height and select the step size, and we use a step of 1 instead of 15. The same to the second slider. And the same modification, the step at the third one. Okay. Click on the name, form, and let's see what happens. You see, we have a finer step and we can control better the modification of the 3 features. Yes? Good. We start by creating a first rule. Right click and add rule. What is its name? Part material is the name. Part underscore material. You see, we have now another dialog box where we develop construction of rules. A rule consists of one or more program lines that produce an action. This is the main purpose of a rule, to produce an action. We create an action to change the material of the part. To do this, we use these snippets. The one we are interested to use is iProperty, because, as you know, the material is defined in the iProperties. We select the word material or the tool material, double click, and in line 2 words appear. The first is the object and the second is the property, separated by a dot. We add an equal sign so that we can assign a value to this pair of words, which are a symbol together. We are supposed to know names of materials, like this one, steel cast, you see here, but we have to respect what is written here, steel cast. Quotation mark, and we write exactly that words, steel, comma, space, cast. This is the only one line we use now. Save and run. Since the material is steel cast, nothing was changed, but the action was made. Be sure of this. Let's see what other materials are in this list. One is aluminum 6061 minus AHC. You see what I show you here, but be careful, because I was not. Aluminum is the word, not aluminium. Yes, this is one. The second is brass, comma, soft yellow. And the last is that one we already used. We want to have 3 definitions for materials. Double click on the rule, the name of the rule, and the rule is again here. Now we select everything, copy, and paste twice. We write here the first name, aluminum blank 6061 minus AHC. Yes, the second one is brass, comma, soft yellow. Now, as you can see, we have 3 definitions. What do you think will happen if we run this program of 3 lines? The first line tells to Inventor to change the actual material to aluminum. The next one to change in brass, and the next one to change in steel. And the result is the one which is now assigned, yes? Since we don't want this, I select these 2 lines and I use from this important line of options, I select this one, which is comment out the selected lines. A program line is an instruction, but if we put an apostrophe as a prefix of the line, then the instruction becomes a comment and is no longer functional. What is now the program? The program is only this first line. To change the material from whatever is now to aluminum. Let's make this. You look here. Steel, cast, yes? Save and run. The material is aluminum 66061, but nothing is changed here. Why? Because the aspect or appearance is the last which was before. Oh, this is not good, yes? Not good. Double click on part material and we make room to add another instruction here. That instruction must change the aspect or appearance, also called as a color, associated with the material. This is why we select the tool Part Color, the color of the part. Double click and you see iProperties dot part color. Between quotation marks we write here default. Yes? Save and run. And now you'll see that this will be changed. Save and run. Yes, it is. And what is this? This is like generic. Oh, but we want other value here. Well, the value is aluminum minus dark, but with spaces. Yes? Let's write these two words to place there. Now you see an asterisk, yes, before the word. This means that this is not the associated aspect with aluminum 6061. Double click here. Instead of default, double click here. We write aluminum blank minus blank dark. Save and run. Look here now. Yes? Save and run. Now you see aluminum. Aluminum dark. Oh, this is very interesting. What about the brass soft yellow? The associated name, which has no asterisk, is brass satin. If I select bronze satin, for instance, the color is this, and you see here an asterisk. This means that this is not the associated aspect for this material. Let's apply. I eliminate comment for this line. Look here, and I apply comment to these two lines, because now I want to make material brass. I select again part color equal quotation mark brass satin is right. is. It is. Let's see. Look here. Save and run. Brass satin without any asterisk before. Good. What about the steel carbon? Not steel carbon, steel cast. Steel cast has semi-polished as an associated aspect. We don't like this one. We didn't use this. We use steel cast, so we'll have an asterisk before, yes? Remember, steel cast with minus like before. Double click. I comment these two lines. Enter. Double click on part color. And I apply here steel line cast. Good. Now when I run, these two lines are the only considered as a program. Look here. Save and run, and we have steel cast, which is not the associated default aspect for steel cast. What we want? We want to associate materials of the part with the height of the part. When the height is bigger, to move from the aluminum to brass and from brass to steel. Oh, this seems to be complicated. No, it isn't. We select all commented lines and we uncomment them. And we separate the pairs. You see? I write here if. If what? If the height, where is the height? The height is at the user parameters or model parameters. Model parameters, you remember the D5 was changed with height, the word height. So I continue by writing here HEIG, and you see that we have an option, height. Double click here. If its value is less than 120, then when the height is less than 120, to have this situation. Else, if we use this, then if the height is less than 140, you remember 115 is the minimum and 145 is the maximum. Yes? When the height is less than 140, we want to change the material to brass. Else means anything else to be steel. What can be? If we know very well that the limits are 115 and 145, here is the situation from 140 to 145. No other possibilities here. And we have to close this with and if. And excuse me. and if. That's all. This is a program. We want to make it beautiful, so I insert an indent to this and this and to this, so to have a easy reading. Yes, we can add a comment here. Yes, apostrophe material depends of height. Something to clarify what happens here. Save and run. Now the question is, how can we connect this with the height? Well, it's very simple. This is what I'm amazed. We go to Forms, click, and we modify the height from the aluminum, which is the first. Now we see that when the height is bigger, the material is changed, and then it is still cast. Yes, we go back, brass, and again aluminum. Oh, very interesting. You think like me? Yes, to me it's very interesting to make some such modification to a part and to obtain the changing of material. Let's go further, but first I would like to reflect a little. As you saw, I created a rule, and when I ran the form, that rule was considered because of the names. Done, rules, material, height is modified by the slider. Yes, when you modify the height, this rule actually changes the material. Yes, so if we place here many rules, they are considered in the form. Good. Next thing I want to make is to associate the number of holes and their disposition in this flange when I change the flange feature, as you remember from yesterday, the second slide. Yes, the second slide, which is the flange. Let's see again. No, threaded feature is the second. Excuse me. I want to use this one because it's more interesting in our crescendo presentation. I want to start with this one, and I write a new rule. Add rule. The name is pattern underscore number. Pattern number. Okay. I want to associate the number of holes in the circular pattern used in the part, to associate this number with the third slider, which is the feature, this one, right click here and capture current state. Everything about the circular pattern is presented here. As you can see, 3 lines. The feature is active. What feature? Circular pattern. Yes, equal true. Active, what means active? Means unsuppressed. Feature can be suppressed or unsuppressed. When you place here a true, then you think this is present, this is unsuppressed. D58 is the parameter for how much of the full circle is used for that pattern, 360 degrees. And the last is the number of holes. Look at me. I apply enter, again circular pattern, capture current state, and I have another similar, identical construction. And the third is this one. I use if then else to make this option, everything to be indented. Yes, and now I write here if what? Well, I go now to all model parameters, threaded feature. Yes, this is threaded feature. If THRE, and we have an option 68. Then you know that this threaded feature is between 55 and 95. So this is a possible step between the limits. Here I write else if, and again threaded is less than say 74, then do this. And the last is else, the last decision, and the closing is and if. Okay, you'll say, but this is unmodified. Yes, now we'll modify. We keep this value 4. Here I place the value 6, and here 8, but not on 360 degrees, but 180 degrees. Save and run. We go to forms, click, and when I move the cursor from here, you see the number. This is not what I wanted, believe me. Oh, you see here modification, yes? Now 180 degrees is fulfilled with 6 holes. I want it to be associated with flanged feature. Yes, this is my mistake. But nothing is difficult here. I leave the value 85 here, done. This is maintained. You see this length. And I go back to the pattern number to associate not with threaded feature, but with flanged FLA, and you see here the option. Save and run. Form. Now the modification is connected with this. You see? What about this? This only make longer or shorter this. Nothing else. Yes? Done. Good. Let's make something with this, the threaded feature. Another rule with the name suppress thread underscore thread. Okay. And now I'm looking to this feature, capture current state, and once again this is all. If if the threaded feature again is less, range is between 55-85, is less than 72, then true. No, then false. Else true. And if I indent this to be nice, these are only for aspect and clarity, legibility, but I forgot then here. If something, then, else, and if. That's all. You have this, I want you to see. If I select here this one, we have some definition. This is another, and this is the last. Yes, but I don't want this to be here, so I use undo. Good. What means this? If the threaded feature is less than 72, then we don't want to see any thread. Else, we want to see the thread. Save and run. You see, now there is no thread here. But when I go to forms and I modify the threaded feature, when I go to 72, we have a thread, yes, here, yes. That limit is respected. Good. F6. The next thing we want to make is to change the color of this flange when we modify the length of the flanged threaded flange feature. Let's see what is that feature. Look, this is, yes, revolution 3. We want to change the color in green. We go to the pattern number, double click, and we create another, but we copy this line, copy, and we place it just here, but not 68. The flanged feature is between 55 and 85, so I select here 70, which is in the middle. Then, and after is and if. Here I look for revolution 3, but not iProperties, which is referring to the whole part, but features. Yes, double click on color. What is the feature name? The feature name is revolution. I have to write revolution 3, exactly the name of here. I can do something for you. Let me do that thing. Delete revolution 3 names, and you see here revolution 3. Clear list again. When you click on anything here, it goes to the names. Revolution 3. Yes, and now I use this name to place here. Double click on it. Again. Clear list. You see the cursor is here between the two quotation marks. I change it, the tab, from parameters to names. I click revolution 3 and I double click revolution 3 because I know where is the cursor placed. Double click. Yes? Good. What is the color? The color is green. And if not, because we have to have a solution, else copy, you think these are difficult things? Tell me, because we are between us. Not difficult, my friends. Default. To be default. We can make some other things here, but let's see these ones. So when I change the second slide, or the third, the color of that feature will be changed. Save and run. Let's see. Form. Where is the flanged feature. Here is, and when I move a little, oh, reverted is. It's green when, of course, I thought to be reverted. Let's change. What is the problem? Double click, I select green, copy to default, and here default. Save and run. Forms, click, this is threaded with or without thread, and now you see from the middle it becomes green. Good. The last thing I want to do is to create a button near the sliders to toggle between existing or not existing this fillet on the part. Let's do this. We create a new rule with the name toggle fillet, and we focus on the fillet. Names, fillet is here. What about fillet? If this is active or not, like the thread before, you remember. Double click, feature is active, but what is the feature name? Double click here, double click here. You know the procedure. Yes? This one equal true is active, true, but we include this in a decision with if feature is active equal true, then we change the feature to be false. If it's true, we want to be false. Yes, we want to toggle. Copy, paste, and false. Else also copy, and if this is without indent and this is with indent, which is a tab. Yes. Now looking better, I see here equal true, but this is superfluous. I have no motive to place here equal true. You see, this object plus property is either true or false. If it is true, then I convert it to be false. If not, I convert it to be true. This is the proper construction. Save and run. I want this last rule to be included in the form, not here, but in a button in the form. I go to the forms, edit form, and I go to rules, click on this and drag to the right. Now you see a new button here. Yes, again I delete this for you, nothing is here, and when I drag this here, the toggle fillet appears on the form. This is the form and this is behind the form. I repeat this for you to know. OK, click here. The other sliders are known. When I toggle fillet, I place where I eliminate the fillet here. Let's make it green. Yes, when I click on toggle fillet, you see all the fillets are disappearing. Yes, look here, appear, disappear. Of course the color is not changed, we can change it, but we have to create two fillets. One is this and the other is the rest, even if they are radius 4, all of them. My friends, that's all. Thanks for watching. Bye bye.